the Ada Lovelace stage today with the amazing Ramin Hasani from Liquid AI. Come on, Ramin, make some noise. Let's go. Great to see you, Ramin. 1, 2.
Hello, hello. All right.
Hello, hello. Awesome stuff. So, Ramin, firstly, just to kind of, we're going to get to like introductions on the company, etc. But I'd love you to very quickly tell us just a little bit about yourself, and then something that would about you that would surprise every member of the audience.
Just starting with that?
Yeah.
All right. Yeah. So, well, I mean, I'm good with math, and you know, I play poker, and I'm pretty good at it. So.
Awesome. Okay. I won't play poker with you, so.
Yeah, we can do that.
I'll make sure to not play poker with you because you'll win. Awesome. Ramin, tell us about Liquid AI. What is it? Why does it exist?
Yeah, absolutely. So Liquid AI, we are a 2-year-old startup, MIT spin-off. We have our headquarters in Boston, and we have an office. We are bi-coastal. We are actually having an office in San Francisco and one in Tokyo, and soon something in Europe as well. And we are a foundation model company. We're building foundation models for devices. So we're bringing the capabilities of, generative AI directly on device. Device could be anything from a robot, a phone, a laptop, let's say a satellite, a car. So whatever you name it. So you can bring this kind of technology on many of these kind of places, because in the future we need to cover more than data centers, and generative AI can bring a lot of value if you actually directly bring them to the edge.
Awesome. The possibilities are endless, and I love how you describe all of those different elements that ultimately AI and also your technology will end up touching. But I think before we kind of go to the future, I'd love to understand a little bit about the journey so far. So tell us how you got here. You've got an amazing credentials as a machine learning scientist. Tell us, how did we get here today?
Yeah, absolutely. So at Liquid AI, we're building foundation models on top of a technology that we invented during my PhD, together with my co-founders. The last 10 years of my research has been in the deep learning and scientific research. Started in Vienna University of Technology, and then continued at MIT. We started looking into brains and physical kind of systems, and we wanted to bring in a lot of priors from natural learning systems back to machine learning. So we started looking into brain of a worm, actually, and this worm is a very tiny little worm. It's called C. elegans. It has 302 neurons in its nervous system. So when I started studying the worm, this worm is very popular because it's one of the most known model organisms in the world, and it has won so far 4 Nobel Prizes for us. So it was a great place to really look into how can we learn some priors about intelligence from the brain of the worm that we can then transfer back to building more sophisticated kind of AI systems. So this led to the invention of something we call liquid neural networks, liquid for adaptability. These are models of physical models of nervous systems, and then from there we managed to control cars, drones, and then basically fixed-wing vehicles. And then we started applying this thing. We figured out the technology itself can model sequential data really well, and then so we started scaling the technology, and we saw great promise in financial time series modeling and also medical time series modeling. That was the predictive AI before the start of Liquid AI. We thought that, okay, so this technology, it has some amazing properties, so we can maybe try to format it and use its properties for building foundation models based on it. So a foundation model, as opposed to a normal model, it has the properties of it's more general in purpose. So it can process multiple tasks. It's not a special. It's an AI system that is not specialized for a certain task, but it is more general. It can also communicate with humans. So it can process text, vision, and audio data as long as all the other types of signals. So then we had to do a bunch of breakthroughs down the way. Like at Liquid, I had to bring in a bunch of very good scientists from MIT and Stanford and Yasha Bengio's lab, all together like their brains to think about how to scale an alternative technology to transformers that can have like multiple properties. The reason why you need such an alternative model, like transformers are amazing and they can perform really well, it's the matter of energy efficiency and because when you think about like larger and larger systems, you want systems that are unconditional. So like transformers. Transformers are matrix multiplications, right? So it's a most elegant way to scale a technology. A simple algorithm, unbiased. It's just two matrices multiplied with each other. That's the attention mechanism. So you can actually scale the technology really well. Then but when you come to the smaller kind of set of elements of computation, the more biases you bring in, the more you can expect the system to behave better. So in a small model regime, you expect biases inside the architecture or changing the architecture to perform better and better, you know? And that's like was the reason why we started. The other thing was energy efficiency, as I mentioned. So transformers are quadratic in computational cost, you know? So as you imagine, the more information they process, the more energy they consume quadratically. So what we built with liquid foundation models is something that is like linear in sequence lengths, you know, or the amount of data that they consume. So that allows the systems to be much more efficient as you scale them. So you can build much larger kind of systems with significantly less amount of compute. And at the same time, you can deploy them anywhere. Because if a model is more efficient, you can bring these models directly on devices. We have today liquid foundation models running directly on Raspberry Pis. So you can actually bring in like a foundation model on the smallest kind of unit of computation to larger and larger instances.
Wow, so it can be applied on, you know, the smallest, most simple device, you know, up to the most complex structures. So did I hear that right? So you looked at a worm, like a worm that moves around on the ground, and you looked into how that works, and then you took knowledge from that and created an AI system.
Yes.
That's remarkable. That's remarkable. And like, what was the where did that idea come from to look at something? I love walking in the countryside, and you see a lot of worms. I'd never think that a worm could become the foundation of, an AI model that's so like how did that idea to focus on that come from?
Yeah, definitely. So, I was always curious about like understanding intelligence, like to see how can we understand like the fundamentals of intelligence in humans, But then when I started like about 12 years ago looking into this problem, we have no idea how the brain works, like we still have no idea. It's like we're so far away from that. Then, so I thought, okay, so let's go to the next best thing. That was the monkey, So we started, like at MIT, where people were looking at monkey's brain, and we started looking at that, and I started realizing that, oh, no, we have no idea also about the monkeys, We don't know that much so that we can actually understand the principles of computation. The next best thing was mice, So, and then also in mice, we know a little bit more, but still not so much. So then so fundamentally, first principle thinking is that like, what's the smallest unit? Like, what's the animal that we know the most about? And this worm, C. elegans, is the name of it. As I told you, why it won 4 Nobel Prizes for us is because this worm is it has 78% genome similarity to humans. So that means whatever you discover about the cell dynamics in this worm can directly transfer to humans as well. So, and the worm has 302 neurons, as opposed to humans that have like 86 to 100 billion neurons, right? So it's a much simpler system that you can actually go and study the cell dynamics. So it was like a, perfect model organism, so to study. And the body of the worm is transparent. A lot of data is available from neuroscience about the worm itself. So we could build like really good mathematical foundation for how the cell dynamics work in the brain of the worm, and then from there, let's make it more and more, evolve it into something that is much more sophisticated.
Wow, that's really awesome. It's incredible. How so? You've gone from this the first principles thinking, looking at a worm. Now you've built Liquid AI into what it is today. How are you applying that in the real world to businesses and to your customers, etc.?
Yeah, absolutely. As I said, the business of the company is bringing foundation models on the edge. So we work with a lot of different, we are a horizontal kind of player. We have the full stack of foundation model development. We are selling 3 pieces of software. One is a pre-training stack, one is a customization stack, and the other one is inference stack. It's a serving stack. These 3 pieces of software enable you to build the foundation models in-house with the best unit economics because the technology is very efficient. Customization stack allows you, again, with the best economics to reduce the cost of basically building specialized kind of AI systems. And our inference stack allows you to deploy these foundation models that are coming. Imagine a ChatGPT that you can directly mount it on top of your phone or inside your laptop. That means whenever, if you don't have access to the internet, you still can use it. So the AI is actually lifted directly on the device. And there is no limitations on the usage. So there is no API limit. There is no need for data centers if the AI actually comes on the device. So in terms of like industries that we are involved with, consumer electronics, we are working with top Fortune 500 companies deploying these things. Like this can be the source of, let's say, mobile intelligence, laptop intelligence, car intelligence, satellite intelligence. You can think about like many home appliances. So think about like wearables in general. So this is basically the space. The market around this thing collectively by 2035 would be around $1 trillion. So and this space is kind of deserted. It's not. We don't have that many players. Like open source has been like active in this kind of domain of small language models that are low latency, private, and all those kind of values that you can get out of these things. But again, this is one of those places that there's no foundation model company that's like 100% focused on this, and we are basically the one that is going like very seriously after this market instead of the cloud.
Yeah, awesome, and that's so interesting. So the device itself becomes the data center ultimately for the AI.
Exactly. So think about device. Today's devices, as I mentioned, like there are phones and laptops, but then future devices are going to be very different. So in the future, form factor might be different. So you might have glasses that are like extremely smart. They might be like pins or whatever like type of device that you would carry with yourself. And the hardware is always like getting better and better. So you can actually bring in better and better models on top of devices. You see, so that's like the space where we want to capture a balance between quality of foundation models, the amount of memory, like because you have to be aware. The most limitations of a hardware kind of system is the memory that is available on the device. So given a memory footprint, how much intelligence can you pack inside the device? That's the kind of balance that we are trying to solve. And then what's the speed of operations that you can unlock with that, with that foundation model?
Awesome. Wow. And so, like you mentioned there, that the niche you're going after is on-device AI, and like there's a lot of conversation. There's different foundational models, different companies that are building them. There's a notion that a lot of the world believe that ultimately we're going to get to a place where there might be one model to rule them all, and it's just going to be omnipresent supercomputer, can understand and solve absolutely everything in the entire world at the same time. And then on the other side, there's the belief that maybe it's going to be a smaller number of very specialized models that are expert in what they do. What's your take on how that's going to play out in the future?
Absolutely. So I believe like with the path that we are taking right now, there are not that many foundation model companies on Earth today. So like OpenAIs and Anthropics of the world that are building basically the largest kind of instances of these models with the hope that we are going to get to super intelligence and models that are very general in knowledge and better than humans. And so those are, I call them oracle builders, companies that can build oracles. So in the future, we would have like oracles. And now imagine these entities, like for sure, at some point in the future, within the next couple of months, I would say, we would have systems that are better than humans. So when you have systems that are better than human, you need to have a safe way to interact with them. So every time you do a call to an oracle and you're asking a personal question, you need to be safe when you're operating with that. So there has to be a protocol. There has to be some sort of an intelligent being that protects you right around you, basically. So the way we are thinking about it is that Liquid is going to be that gate that enables your access to the oracles so that you can have a safe, direct interaction with the oracles of the world. So basically an intelligent system that is like advanced enough that knows that your interactions with the oracle is basically safe, and it can handle your day-to-day job or whatever you want to do, but at the same time, it is allowing you to also access the oracle. So it's going to be like a coexistence of a bunch of oracles and some advanced devices that you would carry with yourself.
Awesome. Wow. So folks, we're just at time. Ramin, it's been an absolutely incredible conversation. I learned something new today. I never would have even thought that something so awesome and sophisticated and something that's going to power the future would start with understanding at a deep level a worm that walks along the ground. Do worms walk?
No.
What do the worms do? How do they move?
They crawl.
They crawl. Okay. Okay, awesome. Well, sometimes you need to crawl and then run and then shoot to the moon. So, Ramin, it's been awesome. Thank you so much for helping kicking us off.
Thanks for having me.
Thank you. Thank you. Pleasure. Ramin Hasani for Liquid AI. Thanks, Ramin.